This video, we are going to see about the topic stack. First of all, we need to know about data structure, then we can go through stack. Data structure is a structure in which the data is stored in a place that can be understood by the developers and as well as the user which is going to use the data next. There are two types of data structures, and they are linear data structure and non-linear data structure. In linear data structure, the data will be arranged in a linear sequence, and the data items can be accessed through traversing in a single run. The linear data structure elements are accessed or placed in contiguous memory locations, like together in sequence. Next, stack. Stack will comes under linear data structure, and stack means last in first out collection. This means the last thing which we add in the stack will be taken out first, like popped out of it. Stack is a sequence of items that are accessible at only one end of the sequence, like there is only one end for stack, in which the place where we that is a place where we insert an item or delete an item. Example of stack: a group of books which is kept over and over. The first book which we keep first will be taken out last, because that is there are only possibilities that there are only one place where we can take the books one by one only, so that last book which we keep on the books will be taken out first. Just like that, the plates the first plate which we keep at the end, at the starting point, will be taken out last. Operations in stack are push, pop, is fully, is empty, and top. Push means we can only push at the top, at the top of the stack. Pop means that also will be done in only single end of the stack. Is full means we need to check that the stack is full or not. Is empty is about if the stack is empty, that will be known as stack underflow. Next, top. Top is the place where we top is the place which would be known as the top only end of the stack. Applications in stack: reversing a string means if we store multiple characters and we push into stack, the first character which we put, we will take at the last. And also we can reverse them by using traversing, by popping one by one. Once the characters are pushed into the stack, that will be taken out by in reverse order. Top. First of all, top is the place where we push or pop the items from the stack. From the beginning, if the stack is empty, the top will be known as -1. While we add the elements into the stack, the top will be incremented. While if we pop out an element from a stack, the top will be decremented. Algorithm for insertion. For insertion, we need 4 elements, which is a, top, item, and max. First of all, we need to check that there is a space for an element to store in the stack. Then if the stack is full, stack overflow, then exit the program. Else, if we can store the elements in the stack, then top which is equal to +1. Then after storing an element, exit. Algorithm for deletion. Deletion, we need three items. They are A, top and item. A, which means the location, the first element, the element which we need to take out of the stack. Then the stack, first we need to check for the stack is empty or not. If the stack is empty, which means stack underflow, then exit the program. Then if we have any elements in it, then we can do top which is equal to -1, which means the element can be deleted from the stack. Then next, stack operations. Stack operations, first we need to check about what I have said earlier is we need to check the stack is empty or the stack is full. Both we need to check in this program. Then if there is an possible way to push an element, we can store it into the stack. Then stack operation, we are pushing second element into it. Then again we are checking the stack is full or not. If there is a possible way, we are adding push second element into our stack. Next, we are adding third element into it. First we need to check the stack is empty. If not, then we are checking the stack is full or the stack is completely filled. If not, we can push the element into it, like we are adding 3 now here. Next we are going to add the fourth element into it. If there is a possible way to add another element, we need to check first there is a possible way to add a value into it. So we are giving 5 as an element as we need to push into it. So there are no space for adding 5 into it. So stack is overflow. Next we are going to pop out an element from the stack. First we are removing first we can only remove the 4 number element, because it is the last thing which we had put into the stack. So it will be first deleted from the stack. Like is the third element, then the second element, then the last final one. These are the stack operations.